Mm.
అది సిస్టమ్ కొంచెం అది స్టక్ అయింది సార్. ఫోన్ నుంచి కనెక్ట్ అయ్యాను ఈరోజు, అందుకే లేట్ అయింది.
Okay. So in the previous class, we have seen how to use synchronization by using either synchronized method or synchronized statement block. But that is, what is the disadvantage in that mechanism of synchronization is we will be indefinitely making the other threads to wait until uh, the current thread which is under execution or which is executing its synchronized block to wait for a long time. అంటే ఒక థ్రెడ్ సింక్రనైజేషన్ లోకి వెళ్తే సింక్రనైజ్డ్ మెథడ్ కానీ బ్లాక్ కానీ కాల్ చేస్తే ఇంకా వేరే అదర్ థ్రెడ్స్ అన్ని కూడా బ్లాక్ అయిపోయి ఉంటాయి. వేరే దాని ఎగ్జిక్యూషన్ కంటిన్యూ అట్లా ఉండిపోతాయి అన్ని థ్రెడ్స్ అందులో వెయిట్ చేస్తుంటాయి కదా. సో దట్ ఈస్ నాట్ ఏ పవర్ఫుల్, ఇట్ ఈస్ యూస్ఫుల్, it will be it will not allow any inconsistency in the data or whatever is being manipulated. So because of lack of synchronization, inconsistency will happen. What is inconsistency means? The example that I told you, bank example, withdrawing of money. So that is called as that state of bank account being manipulated due to lack of synchronization, which we call it as inconsistency. So we can avoid inconsistency using the synchronized method or synchronized block, but that will increase the time of execution of the threads. Right? So we'll see another mechanism called inter-thread communication in place of synchronized method or synchronized block. The use of implicit monitors in Java that we were seeing in the previous version, it is powerful, but you can achieve a more subtle level of control through inter-process communication, which is especially easy in Java. Threads also provide a benefit. They do away with the polling. Polling is usually implemented by a loop that is used to check some condition repeatedly. Once the condition is true, appropriate action is taken. This wastes CPU time. So polling is another alternative to synchronization. So here, in case of synchronized method or block, what is happening is the threads will be blocked. Whichever thread is waiting for that synchronized or shared resource, that will be blocked until the current thread completes its execution. And again, if there are multiple threads waiting for the same shared resource, we cannot say which thread is going to be given the resource, and again the other threads have to be in waiting state, suspended state, right? The alternative for that is, another alternative is a polling mechanism. Polling mechanism means the threads keep on executing instead of executing with the CPU or some other shared resource. They will be continuously executing some instructions. That instruction will be checking always the status of the previous thread which is currently using the shared resource, but continuously executing that also, what is going to do is it is going to waste the CPU time unnecessarily. It is not going to perform any useful activity unnecessarily. It is going to perform continuously keeping on checking whether it comes or not. See, for example, uh, you are supposed to wake up early in the morning at 4 a.m. So what will you do to wake up? There are two ways for you. If there is no alarm concept and all in your mobile, you don't have a mobile or you don't have a alarm clock, then what you'll do, whenever you wake up in the middle, you will be seeing the time, right? So will it make you to sleep properly the whole night? You will be always keeping on continuously watching when the time will become 4 a.m. 4 a.m. So I have to wake up, right? But instead of that, if you have an alarm mechanism which gives you a notification, you can sleep without any uh, tensions and everything. Normally, when it becomes 4 a.m., the alarm will ring and then you can wake up at that time. So that is the difference between using an alarm or notification kind of thing instead of continuously keeping on checking whether it has become 4 a.m. or not. So in the same way, polling is a mechanism in which we don't have any alarm kind of thing. So we continuously keep checking whether the resource has become available or not, or it is busy. So this will be wasting your time instead of you taking care of other work, right? So that is also not a suggested mechanism. So to avoid polling, Java includes an elegant inter-process communication mechanism via the methods called wait, notify, and notify all methods. So these three methods we are going to use to avoid such polling mechanism and synchronized or synchronized method concept. Instead of using them, we are going to use a more efficient way, which is nothing but called inter-process communication. That means what? Uh, all the threads which are waiting for that, which are requesting for the shared resource, will communicate with each other. Okay, so these methods, wait, notify, and notify all. These are all final methods. They are defined in a class called object class. So I told you long back that object is a predefined class, and it is a super class for all the other classes in our program, in our Java program. It is a super class for all the other classes. Any class you take, even you define your own class in your program, even that also will become automatically an subclass for this object. So that's why we call object is a superclass for all the classes, right? And any class will have this method. You can directly use them because it is a superclass for all the classes. These methods are implemented as final methods in object class, so all classes have them. All three methods can be called only from within a synchronized context. But when you are making a call to this wait, notify, and notify all, we need to make a call to them from synchronized context. It means synchronized block or synchronized method. The rules for using these methods are actually quite simple. What is wait method going to do is it tells the calling thread to give up the monitor and go to sleep until some other thread enters the same monitor and calls notify. Notify wakes up a thread that called wait on the same object. Notify all wakes up all the threads that call the wait on the same object. One of the threads will be granted access. That means what? So once a thread is utilizing a shared resource, then all the other threads which are requesting for the same resource at the time this thread is using uh, will be calling the wait method upon this shared resource, and they'll be waiting until this thread completes its the first thread which is utilizing the shared resource completes its uh, operation, and then all the other threads, whether it is single thread or multiple threads that are waiting on the shared resource, will be given a notification. They need not continuously keep checking whether it has been completed or not, right? So this will give a notification to all the other threads. So what is going to happen is the thread which enters the same monitor will be qualifying the notify method, and notify method what it does is it is going to wake all the other threads that are waiting for all. So notify method will give only will wake only one thread. Notify all will give call to all the threads that are waiting. So if there is only one thread, you can use notify. If there are multiple threads, then you can use notify all. So these methods are declared within object with this following syntaxes. They are all final methods, so you cannot override them in your class. So wait method has a return type void. It doesn't receive any parameters and it throws interrupted exception. Notify method does not have any parameters and its return type is void. Notify all also does not have any parameters and its return type is void. So I'll show you one program first without based on a problem called producer and consumer problem. So you must have already known about this producer and consumer problem in operating system subject. What is a producer and what is a consumer? A producer is one which produces an item that must be consumed by the consumer. Always we should see that both producer and consumer are communicating with each other and synchronizing with each other, so that producer will not produce more number of items and overwhelm the consumer, and similarly consumer will not uh, be waiting for the producer will be trying to consume an item when there is no item. So that should not happen. So to avoid such situations, we have to use some synchronization or inter-thread communication in our program. But this version of the program, we don't use the inter-thread communication. We directly use only the synchronized method concept. So in the previous program, we have seen using a synchronized block, right? So instead of that synchronized block, we can also use synchronized method I told you. So instead of creating a synchronized block and calling from that block the shared method, the shared resource, we can make that method itself as a synchronized method, right? By using the keyword synchronized keyword in front of this method definition. As such, we are defining a class called Q, and this class has two methods, get method and put method, and there is an integer variable n. So this is the item that must be consumed by the uh, consumer and that is produced by the producer. So producer, what it does is it will make a call to the put method, and consumer will make a call to the get method. Consumer wants to consume, so it will call the get method, and producer will be producing, and it is going to call the put method. So the put method has one integer parameter, that is n. So this n will be assigned to this n variable. So this dot n is equal to n, and then we'll display a message system.out.println one item produced and placed so in the buffer, so that consumer can consume. Okay. Then similarly, get method will be called by the consumer. So whenever it calls the get method, it will display yes, received one item. So producer will send an item that is produced, and consumer will receive that item, the same item, and it will display whatever item it has consumed, and it is going to return n. So whatever item it has consumed, that value will be returned. So that's why the return type of get is int, whereas for put the return type is void. So and then we have another class called producer class, which will be implementing the runnable interface, because we need to create producer thread and consumer thread. Two different threads must be created. Similarly, we'll have a consumer class also, which also implements the runnable interface, and then we'll have finally the PC class, which has the main method. Okay. So in the producer class, uh, we'll be creating a reference variable for Q class, which is small q, and then we defined a constructor for producer class, which also receives q type of object as parameter. Then this q will be assigned with this parameter q, this dot q is equal to q, and a new thread is created by using the uh, first version of the thread constructor, which receives this keyword and the uh, name of the thread as parameter in the form of a string. And soon after this object is created, I'm not creating any thread reference variable here, right? So that's why directly dot start I'm calling. So immediately I'm making a call to the start method. Then the start method in turn will make a call to the run method. So what is run method going to do is it is declaring a variable I of integer and initializing it to 0, and while true, so this condition will always will be true, then this will be continuously making a call to the put method. Okay, this will be continuously making a call to the put method. So put method, what is it doing? It is incrementing I value and then making a call. So I value will be first incremented, will be sent first and then incremented. So it will become 1. So when it is called, that 1 will be sent to this put method, and that will be assigned to n, and then uh, put method will display that variable n's value. Then similarly, consumer, what it does is it will have the same queue type of object reference variable, and constructor will receive a queue type object, and that will be assigned to this dot queue, and new thread is created and the name of the thread is given as consumer, and it will call the start method, and again start method in turn will call run method, and this also has the same while loop with the true condition, but this time the consumer will make a call to get method, producer will make a call to put method, consumer will make a call to get method. So this is how producer class, consumer class, and queue class are defined. Then in the PC class, we define the main method and we create an object for queue class. Then we instantiate producer class, so the constructor of producer will be called, and then thread will be created, and start method will be called, and run method will be called. So producer thread starts running and producing by making a call to the put method. Similarly, next we'll make a call to the constructor of a consumer class, and this also will uh, will create the thread and call the start method, and start method in turn will call the run method, and that also will try to consume, and later we'll display we are displaying a message, press Control C to stop, right? So what is going to happen is there is no proper synchronization here, even though we are using synchronized methods there, right? We are using synchronized methods, but the output is not efficient, it is not correct. So look at the put method. Put method first, that is producer method, has put item number 1 first, and the consumer has received that item number 1. But later, in the next time the loop is repeated, it is continuously consuming the same 1 1 1 for how many times? 1 2 3 4 more times. Then after that, put method has put the second. The producer has put the second item, but consumer has not completed consuming it, right? Then producer has again put another item 3, then 4 5 6 7 also. Then later consumer is receiving 7. So what is happening to 2 3 4 5 6? They are missed by the consumer, right? So that should not happen. So what we need to do is soon after one item is produced and placed, immediately it has to be consumed. Then again another item produced, and immediately the consumer has to consume it. So everything must happen in a proper way. Such one is put, one is consumed. Then two is put, two is consumed. Three is put, three is consumed immediately. So in that way, there must be switching between producer and consumer threads. But that is not going to happen here in this case. So let me execute this program and show it to you the output. So that will be because the while loop is an infinite loop. We didn't put an end to while loop with a condition. So this will be continuing continuously. So if you want to exit, you have to press Control C. What is happening? See, 0 is put, then 1 is put, 2 is put, 3 is put, 4 is put, 5 is put, 6 is put, 7, 8, 9, 10, 11, 12, 13. So how many times the put is called? And after some time, we are making a call to consumer is executing. Consumer executes starting from 84 items. So all the previous items 1 to 83 are missed by the consumer because the consumer did not respond in time. It was suspended and it didn't respond immediately. So it has missed all the first 83 items. Then it has started receiving 84. But after that also it is continuously receiving only the same item. It is not receiving 85. 84 is 84 is received. Then 85 is put again. 85 is received. How many times it is receiving 85? So many times. Then producer is producing again 86, 7, 8, 9, 90, 91, 92, so on. So this is indefinite. So we should avoid such situation. So to do that, what we'll do is we'll use an alternative mechanism by using this wait method, notify and notify all method. This is the correct implementation of producer and consumer. We'll have the same class Q, and also we'll have producer class which implements runnable, and consumer class which implements runnable, and the PC class now is modified to PC fixed, right? So the program is almost same, except we'll make small changes in using this wait method and notify methods, and additionally we'll create a boolean variable value set. So the class Q has the same instance variable integer n and a boolean variable called value set, which is set to initialize to false. Then we'll make this get method synchronous as we have done in the previous program. But inside this get method, we have a while loop. Instead of using truth value always, we are using value set variable, not of value set variable, which is initially set to false, right? So if the value set variable's value is false, not of false will become true. If it is true, not of true will become false. So when it is false, this while loop will continue its execution. When it is true, it will not continue the while loop, right? And then after the while loop is exited, you will print got n, whichever item is received by the producer, that will be message. Then value set will be made to false. Then notify method is called. Return method will return the value from wherever you call this uh, get method. And where you are calling this get method, the consumer is calling the get method in the while loop, in its run method in while loop, right? So q dot get. So here this is going to return. First, let me copy this program and run this, and then I'll explain you how the execution will go. See, the producer puts 0, then consumer gets 0. Then after that, producer puts 1, consumer gets 1, puts 2, gets 2, put 2, 3, get 3, get 5, 4, put 5, get 5. Right? So this is how the producer consumer problem can be restricted and implemented in an efficient manner so that consumer will not try to consume an item when there is no item produced. Similarly, producer will not produce an item when the consumer has not consumed the previous item. Earlier, what is happening is, even though consumer is not ready to consume, the producer is producing and placing an item. And even when producer has not produced an item, consumer is trying to consume an item. So this is the irregularity we found in the previous version, but that is not the case here. When the producer produces an item and places it, then the consumer will consume, and after consumer consumed it, then only producer will produce the next item. So that is how there is a coordination or synchronization between the producer and consumer. So this is happening only because we fixed that problem this way. See, initially, let us assume that uh, we'll start the execution from the main method, because when we run the program, the main is the first method to execute. And what we are doing here is we are creating an object for Q class. Then we are instantiating the producer class by passing this Q as an object. So once the producer object is instantiated, the producer class constructor will start executing, and that will receive that Q object that is created there in the main method. That will be assigned to this reference variable Q here. So this Q is nothing but equivalent to this Q node. So then we create a thread here, instantiated thread, and give its name as producer, and then make a call to the start method. And start method in turn will make a call to the run method. And the run method, what it does is it will initialize I value with 0. Then the condition here mentioned is while I less than or equal to 5. So we are going to produce only 5 items. We are not going to produce a large number of items. So we are taking the buffer size as only 5. So as long as the condition is true, this while loop will execute and it will be making a call to put method. So when I is equal to 0, this put method will be called using this Q object Q dot put, and I plus plus will be passed. Because this is post increment, instead of passing the incremented value, it will pass the previous value. I value is 0, that will be passed, right? So when I is passed with 0, when put is called with 0 as parameter, then the put method gets executed. So look at the put method. What is their input method? What is it doing? So the put method has a while loop, and this while loop has a value set variable, and value set is initialized to false. Right. So let us assume that the thread uh, that is consumer thread has not yet been created. Only producer thread has been created for the first time. Then this value set will remain false. Right. It will remain false. So when it is false, what is happening? Will this while loop be executed? It is not going to be executed. So if it is not going to be executed, this will happen. This dot n will be assigned with n. That means n value will be assigned with which value? N. This n is nothing but 0. So 0 will be assigned to this uh, instance variable n. Then we are making the value set variable to true. Then we'll print put n. Put n means put 0. Then we'll call the notify method. Right. So notify method, what it does, it will notify whichever thread is trying to make a call to the get method, because this is a synchronized method. So to do that, what we need to do is we need to make both put method and get method as synchronized. We need to qualify them as synchronized, then only this will work. If we don't use synchronized method, then normally it will work. Okay. So the notify method, what is it going to do? It is going to, as I told you in the slide, it wakes up a thread that called wait on the same object. The same object means what? The same item object, the class Q, right? So uh, if the consumer thread has already made a call to the get method using the same Q object, then that method will be making a call to wait method here. Observe here, right? So when this wait method will be called, if this condition becomes true, and when this will become true, say for example, producer has not placed an item. For example, it has not yet executed this while loop, right? It has not made a call to try method. So put method has a while loop, right? It has a value set variable. Then if this value set variable is not set true there, then what is going to happen? This is going to be executed and this is going to set it to true. So when this is set to true, what is this going to happen? This will become false, right? Not of true means false. So that means what? It will not enter into the while loop. If it is not entering into the while loop, then it will continue with this execution. So what is this going to do? It is going to display a message got n, and what is n value? 0. And then again, what is it this going to do? It is going to set the value set variable to false and then make a call to notify method, right? So at this time, if the uh, producer thread has made a call to this put method, it will be waiting. So both the methods will going to wait, but when they are going to go into a wait state, so if this is not false, if this is not set false, earlier the producer has set this to true, right? So again, if the producer tries to execute this while loop, then what is going to happen? This will be true. Then if this is true, then it will enter into the while loop and then make a call to the wait method. So what is wait method going to do? Wait method will suspend the producer thread, right? But how will the producer will know that it has to complete its waiting and come back and resume its execution? Because the thread, this thread, consumer thread, will consume the item and set this value to false, right? So when this is set to false, then uh, uh, this condition will become false. So the while the producer thread will not enter into this while loop, and it will produce an item and um, display a message put and then make a call to notify method. So until that happens, it will stay in this while loop only. It will stay in the while loop only. So when this will come out of this while loop, when it is notified about, because it has already called the wait method. So whenever a thread calls a wait method, it will be automatically informed uh, about the completion of consumption by the consumer thread when the consumer thread makes a call to the notify method. So that is the reason why both the consumer thread and producer thread are making a call to notify method, because when if this notify method is not called, the producer thread will not be knowing about whether the consumer has consumed it or not. If it doesn't know, then it will be in a waiting state only. So to avoid such situation, we are going to use notify method. Notify method, what is it going to do? It is going to inform the waiting threads. What is wait method going to do? It is going to suspend that thread, whichever call that wait method, it is going to that thread is going to be suspended until again it gets a notification from the other thread which has completed its uh, consumption or execution, whatever it is. So that is how threads will communicate with each other by using this wait and notify methods. So in this case, in this scenario, there are only two threads. One is producer thread and the other one is consumer thread. So in that case, we can use only notify method. But if there are more than two threads, then if one thread is utilizing the shared resource, the other threads, what they are going to do is they're going to wait. So if we want to inform all the other threads about the completion of that current thread execution, then we can call that notify all method. Then notify all method will all what it does is it will inform all the threads that are in a suspended state or waiting state about the completion of this task. So one of them will be given a chance, and then all the other threads will now again go back to waiting state. So this is how notify and notify all methods will work. So this is about notify method. See, this is a little bit difficult and confusing concept, because we have to switch our minds just like threads will be switching between the CPU or the shared resources. Then only you'll be able to understand. So let us take some test cases, then we'll understand. So initially, we didn't start executing this program. So both producer and consumer will be idle. So now when we start first, begin with execution. First, producer has to produce an item, then only consumer can consume the item. So that is the reason for which we are first creating producer object, right? Before consumer, we are creating producer object, so that producer will produce an item and place an item, and then later consumer item, right? So main thread will begin execution first. The main thread will uh, create a child thread by making a call to the producer class. So producer constructor gets executed, and the new thread is created, and the start method will be called. And start method in turn will make a call to the run method. And in the run method, I variable is created and initialized to 0. Then we'll make a call to this put method how many times? 5 times. From I value 0 to I value, sorry, 6 times we'll make a call. So 0 to 5, right? So initially when I value is 0, we'll make a call to put method. And put method will pass that I0's value. Sorry. Uh, Put method will be called with the I value 0 as parameter, and then later I value will be incremented to 1. So when we come back to this while loop next iteration, then that time 1 will be passed. Now 0 will be passed. So when this put method is called, the control will go to the put method. Where is the put method? Here is the put method. So this n will receive 0, right? And we have assumed that uh, we didn't wake up the consumer process thread, right? So initially, uh, value set variable. What is the value set variable? This one. This is initially set to false, right? So now this is the current situation. Value set is false, and the producer method has been put method has been called by the producer thread, and then when it invokes this put method, the while loop will be executed. And what is value set variable's value? It is false. Let us assume that the consumer thread has not been invoked yet, right? So now this value set will be false. If this is false, the while loop will not be executed, and we'll come here and we'll execute this statement. So what is this statement doing? The value n, the parameter n value is initialized to is assigned to the instance variable n. So instance variable n will become 0. Then value set is made to true. Value set is made to true, right? Then it will display this message put n, and value is 0. So the producer thread will display a message put 0, and then it will make a call to notify method. It will make a call to the notify method. Let us assume that at the time when we are putting when we put this statement, when we display this statement, the consumer thread has also been invoked. The consumer thread has also been invoked, because switching will take place. We don't know when the switching will take place, right? The CPU may be switching when the producer is executing this statement or this statement or this statement or this statement. We don't know when the switching will take place, because it is not dependent in our program. It is dependent on the CPU hardware. The CPU may switch at any time. As such, let us assume that uh, after we exited this while loop, at this when we were executing this statement, the CPU has switched. So if it is switching, then we'll go back to which one? The main thread, right? Because at this point only main thread and producer thread have been created. So when we go back to the main thread, what is the next statement in the main thread? The consumer thread is created. Right? So now consumer thread will be starting its execution. Right? So the value set is still false only. It is not set to true. We are assuming that we are switching from to main thread when you are at this executing this instruction. After executing this instruction, the main thread has switched to the CPU has switched to the main thread. So that means what? The value set is still not set to true. It is to the previous value, that is false. So the consumer thread, what is it going to do? It is going to make a call to the start method, and start method in turn will make a call to the run method. And here also I is initialized to 0 here, and while loop will execute the same way, and the get method will be called, and get method will receive what? It will check this while loop, and while loop, what is going to happen to the while loop? The value set which was earlier false, right? So if it is false means what? Not of false means true. So that means the condition becomes true, and the consumer thread will enter into this for loop, this while loop, and then the while loop you have a try block. In the try block, you are making a call to the wait method. So that means wait method, when it is called, what is going to happen to the consumer thread? It will be suspended. So why you are making this consumer thread to be suspended means because the producer has not produced the item yet. We have been executing till which statement? Which statement is being executed by the producer? This statement, right? We didn't execute this one. So once we complete executing this statement, what does it indicate? The value set is set to true means yes, we have produced an item. Right? Then we'll put this item. Then we'll make a call to the notify. So why this notify will be called means now this thread consumer thread will enter into wait state, right? So when it is entering into the wait state, what the CPU has to do, it has to switch. So when it will switch, it will go back to the main thread, but main thread has nothing. So it has one system.out.println statement. So it may execute this one. So after executing this one, are there any threads available? Is there any code available in the main thread? So there is no other code. So the CPU will switch to the producer thread, right? So when it switches to producer thread, what is producer thread? Where it has been stopped, it has been stopped here, right? So it will continue its execution. So it will set the value set to true, and then it will display this message 0, and then make a call to the notify method. So when the notify method is called, earlier the consumer thread has been entered into the waiting state by calling a wait method. So that is the only thread available which is waiting on the same object for Q class, right? So what is going to happen to the consumer thread is it will be coming out of the suspension state. It will resume its execution. So if it resumes its execution, then it will come out of this try catch block, and start continuing with this instruction. So this will display a message got 0, and then it will set the value set variable to false. So when this is set to false, then say for example, after displaying this message, the CPU has switched from consumer thread to producer thread. So when the producer thread starts executing its put method, what will be value set? Value set will be true because it has not yet modified this value set variable to false. Consumer has not yet modified this value set to false, right? So what is going to happen to the producer thread is the value set will still remain true. So when it enters into this put method again, then this will become true, and as a result this producer will go into the wait state. So if this is entering into the wait state, then the CPU has to switch to which thread? The consumer thread. So consumer thread will again continue its execution, and then set this value set variable to false. And after making this variable false, then it will make a call to notify method. So when this notify method is called again, the producer thread will come out of this waiting state, and then it will continue with this one, right? So when this is continued, this variable n value will be incremented, right? Here we are incrementing in this while loop. So how many times you'll be making call to this put method? Yeah, for every iteration, right? From value I0 to 5, 6 times it will be making a call. So this time, put integer n value is 1. So this will assign that one to this method instance variable n, and then set to true, and then display this, and then make a call to notify. So again, consumer will resume, and consumer will continue this. Then again it will set to false, then notify, then return. In this way, switching will take place between producer and consumer. And if consumer is trying to consume an item even before the producer has produced, it will be sent into wait state, and the producer will continue its execution. And after producer completes its part, then it will call a notify method. Then the consumer will be notified, and it will come out of that suspension state and continue consuming. And after consuming again, it will reset the value set variable to false and call notify method, because if, at this point of time, if the producer also tries to execute, then the producer also will enter into wait state, right? So then when you call this notify method, producer will come out of the waiting state and then produce an item. So in that way, both will be communicating with each other by with the help of this wait and notify method. Understood?
So a little bit confusion is there, sir.
కన్ఫ్యూజన్ ఉంటుంది.
Yes, sir.
ఆ ప్రాసెస్ తెలుసు కదా, మెయిన్ థ్రెడ్ ఎగ్జిక్యూషన్ స్టార్ట్ అవుతుంది, తర్వాత ప్రొడ్యూసర్ స్టార్ట్ అవుతుంది. ఆ వేరియబుల్స్ ని ఒకసారి అన్ని లూప్స్ అంటే ఇప్పుడు నేను 6 ఇటరేషన్స్ చెప్పాలంటే ఇంకొక అరగంట అయినా పడుతుంది.
అదే సార్.
సో
నేను
అందుకనే
ఒకసారి ట్రై చేస్తాను సార్.
నువ్వే అవి సబ్స్టిట్యూషన్స్ చేసుకొని ఆ వాల్యూస్ ని స్విచ్చింగ్ జరుగుతున్నప్పుడు ఎలా అవుతుంది ఏంటనేది ఒకసారి చూసుకో, అర్థమవుతుంది.
ఓకే సార్.
ఒక పేపర్ మీద పెట్టుకొని అవన్నీ చేసుకుంటూ వెళ్తే అర్థమవుతుంది. ఇప్పుడు అది నేను చేయాలనుకో నాకు ఇంకా అట్లీస్ట్ హాఫ్ అన్ అవర్ పడుతుంది ఈ
అదే సార్.
ప్రోగ్రామ్.
మీరు ఆల్రెడీ 2 టైమ్స్ ఎక్స్‌ప్లెయిన్ చేశారు.
ఓకే,
నేను ట్రై చేస్తాను సార్.
సో ఈ ఫస్ట్ ఇది కంప్లీట్ చేసుకున్న తర్వాత కంటిన్యూ చేద్దాం నెక్స్ట్.
ఓకే సార్.
సో టుమారో అంటే రేపు కదా, మండే మీట్ అవుతాం.
ఓకే సార్.
రైట్.